Hello, this is Mrs. Spellman. Welcome to GCSE Computer Science. Let's get started. Today we're looking at memory and storage. It is a red topic. We're just looking at one bullet point, so pause the video and take stock of where you are right now. Once you've done that, if you fill in this slip in your green book. And now we're ready to learn. This is a recap from the last video. So we're looking at the hexadecimal number 7e, and we know that that means 7 times 16 plus 14, and altogether that gives us 126. So if you are familiar with this and happy with this, well then you're ready for this video. Otherwise, you probably need to watch the previous video and master that before moving on to this. While we're looking at this screen, there's something I want to point out. So here we have the 16 times table, and we use that when we're converting in hexadecimal. It's helpful to have that close by. But if we think about the column headings for a binary number, so think about a byte, we've got our 1, 2, 4, 8, then we have 16, 32, 64, and 128. So all our column headings for the left part of the byte are actually represented in the 16 times tables. Okay, so first exercise for you. Could you pause the video and have a go at converting 40 into binary and hexadecimal? Okay, I'm about to reveal the answer. So in hexadecimal, it's 2 times 16, which is 32, plus 8, which is 40. And in binary, it's 132 and 18. So if you see, there's a nice little pattern going on here. This bit is shown in this nibble, and this bit here is shown in this nibble. So what I'm going to do is we're going to split this byte into two, and I've relabeled this one with a 1, 2, 4, 8. And now in this nibble we have the value 2, and in this we have the value 8. 2, 8. So binary and hexadecimal are very easy to convert to each other because of this. And this is one of the reasons computer scientists use hexadecimal, because it's so easy to convert the binary that the machine works with to hexadecimal. The other reason is humans find it very difficult to read binary. It's just lots of ones and zeros. So if we can shorten that down into a more meaningful pattern, well, that will be easier to read. So that's the other reason why computer scientists use hexadecimal. And you may have seen hexadecimal numbers before when you're choosing a color from a color palette in an application. And it's a lot easier there and a lot shorter to show the hexadecimal than the binary value. Okay, we're going to convert this hexadecimal number to binary together. So we've got 2a here. So let's split that into two. And we're going to show it as nibbles. So the 2 is shown there with a 1 under the 2, and the 10 is shown with an 8 and a 2. So we're actually, if we didn't see those labels on top and we squash those numbers back together, we're looking at the binary number, we're looking at the answer. So let's do just that. There, we've squashed the labels together and relabeled it, and that's our answer. Okay, if you have a go at doing this one. So again, I'm about to show the answer. Split them into two nibbles, giving them the correct values, and remember to label your nibble over here to 1, 2, 4, 8, otherwise it won't make sense. But once you've done that, you squash the number back together again and relabel it correctly. And that's your answer. Okay, one more, hex to binary. Okay, I'm about to reveal the answer. So again, we've got two nibbles, 10 on the left, 5 on the right. Squash them back together and make sure we've got the correct labels. And That's your answer. And now we're going to do it the other way around, so binary to hexadecimal. So what I'm going to do is split that nibble in two and work out the values that are in the nibbles. So here 1 and 1 is 5, and over here we have 1 under the 8, 1 under the 2, which gives us 10, which is A. And for our answer, we're going to squash that A and 5 back together, like that. Okay, let's try another one. So if you pause the video and have a go at this, and now I'm about to reveal the answer. So we've split them into two nibbles, relabeled the columns, and we've got 1, 1 on the left, which is 3, and 1, 0, 1, 0 on the right, which is A. And now we're going to squash those back together again. So that's it for now. Remember, you can go on to Maths Fun website, to the binary to denary to hexadecimal converter, where you can give yourself lots more of exercises and then check your answers. But I'm going to show you a different website now, and this is a game called Flippy Bit and the Attack of the Hexadecimals. It's a great game for practicing converting hexadecimal to binary. So let's have a look. So on this side of the screen here, you can see there was a bird falling down with a 7-4 on it. That's a hexadecimal number. And down here, I am working out the binary equivalent, and I've got it right, so it's going to, kill the bird. And that continues. I'm doing my 7 and my 2 there. This next one coming down is E and A here. So again, down here, I would get my 14 and my 10 ready. And I think one more, 4 and F on the right is all the bits for the middle. So I really recommend that one for practicing. And in fact, I had a student say to me at the beginning of the lesson, I'm never going to get this hexadecimal to binary. And at the end, she said to me, I can do that in my head now. So, really good resource here. Okay, so what have we learned? We've learned that hexadecimal converts easily to binary and vice versa, and that's one reason why computer scientists use it. And the other reason that they use it is it's easier to read hexadecimal than binary. Have a look now at where you are with your knowledge on this bullet point. Fill in the slip. That is it for now. I hope that you have made progress in this lesson.